Ohayou gozaimasu. I'm very excited to be here today to talk about real-world mocking in Swift. You want to write tests, but you don't want them to mess up your real stuff, or be slow. Here's a simple example of an NSURL session you might have in your codebase. If you want to make a real request, your test will be slow. Also, asynchronous tests are not reliable. The more tests you have, the higher the likelihood one or more fail randomly. But how do you test this without making a real request? OCMock can't save you now. Technically, you can use OCMock with Swift, but only with severe restrictions, and functionality is still limited, so there is no point in trying to use it. Mocking frameworks are all built on top of reflection, taking advantage of being able to change classes, types, and objects at runtime. Swift is currently read-only, so there's no way to modify your program at runtime. It doesn't seem like it'll change, since it's part of what makes Swift such a safe programming language. We'll see at the end that Swift does have some mocking frameworks currently, but they are different than what you'd find in languages with more access to the language runtime. As a result, we'll need to write our own mocks. We first create a mock URL session and inject it. Then we call get with a referenced URL. Finally, we assert that the URL the session received was the same one we passed in. Some hard truths. It will take a lot of time. Writing your own mocks will definitely take more time than having OCMock create them for you. But I will show you ways to make this take less time. You will wonder if it's worth it. For every mock you write, you have to think about whether using the real type is worth the time you will spend writing, integrating, and maintaining a mock. I will show you how to think about this trade-off and only write mocks that are worth the investment. So why use mocks? There are 3 excellent reasons. First, it makes your tests faster, like thousands of times faster. Web servers, databases, and services over the network run thousands of times slower than computer instructions, slowing down the tests. Slow tests don't get run as often and are thus not as useful. Second, it increases the coverage of your test suite. Error conditions and exceptions are nearly impossible to test without mocks that can simulate them. Functions that perform dangerous tasks, such as deleting files or deleting database tables, are difficult to safely test without mocks. Finally, it makes tests more robust. Without mocks, the tests are sensitive to faults in part of the system that are not related to what is being tested. Network timings can be thrown off by an unexpected computer load. Databases may contain extra or missing rows. Configuration files may have been modified. I know testing is not as common in iOS development, But there are lots of great reasons to do it, and do it now. The book, The Effective Engineer by Edmund Lau, had a huge effect on me. It convinced me that adding tests was one of the highest leverage improvements I could make to our code base. Some reasons why. It allows engineers to make changes, especially large refactorings, with significantly higher confidence. I know if I want to rethink how we do networking, try out reactive Cocoa, or improve our utilities for concurrency, I want to have tests in place so I don't break anything. If you want to improve your application, testing is the first place you should look. It decreases bugs and the repetitive work of manual testing. When code does break, automated tests help to efficiently identify who's accountable. Tests also offer executable documentation of what cases the original author considered and how to invoke the code. The time to write tests is now. Writing tests is done more easily by the original authors when their code is fresh in their minds. Rather than by those who try to modify it months or years later. Fostering a culture of testing on a team will take time and effort. It's best to start the process now. One technique we'll use in our tests is dependency injection. Here, we use multiple constructor injection with a default constructor. The default constructor is a convenient way to initialize a type with all real dependencies without needing to pass in any arguments. This is considered a bad practice by Java programmers and has the title Bastard Injection. However, that is mostly because it causes issues when you use a dependency injection container, either rolling your own or through a framework like Typhoon or Swinject. If you aren't doing that, then it's not actually a bad practice. Dependency injection is a $25 term for a 5-cent concept. Dependency injection means giving an object its instance variables. Really, that's it. You might wonder, why not just use a singleton? This is a one-line singleton for a video upload manager. It is then used in the Time Machine API to upload a video. We have 3 great reasons to use dependency injection. First is easy customization. When creating an object, it's easy to customize parts of it for specific scenarios instead of using the same singleton everywhere. Second, we have clear ownership. Particularly when using constructor injection, the object ownership rules are strictly enforced, helping to avoid circular dependencies. Finally, we have testability. No hidden dependencies need to be managed. It becomes easy to mock out the dependencies to focus our tests on the object being tested. There are several main forms of dependency injection, but constructor injection is generally preferred because it makes dependencies explicit. I will be using constructor injection in all my examples. Using dependency injection, we can pass in test doubles instead of the real objects. OCMock made it easy to create stubs, mocks, and partial mocks. In looking at many resources on testing, I found that the definitions used for these terms was consistent within iOS and also consistent with Java. This is important because Java is where we find some of the most authoritative resources on the topic and where mocks were originally developed. First, stubs. They fake a response to method calls of an object. Some of the most common stubs are for APIs. They give you fake responses instead of hitting the real API. This is also useful when you're relying on an API that hasn't been built yet, like this API. We're going to indulge in some sci-fi APIs. The API call to the time machine API would make the time machine go to the provided year, take a short video of what it sees, and upload it to YouTube when it gets back to the present. The stub API call will return a hard-coded video URL instead of actually calling the API. Mocks are a little more complex. They let you check if a method call is performed or if a property is set. This time machine allows you to travel to any year you want. Our mock time machine has a variable time travel was called. When we call time travel to, time travel was called is set to true. This allows us to test that the function we want to get called actually gets called. Partial mocks are any actual object which has been wrapped or changed. To provide artificial responses to some methods, but not others. Partial mocks are an anti-pattern. I will not encourage you to use them, nor will I go into detail on how you can create and use them in your Swift apps. Now, I don't take the word anti-pattern lightly, so let me explain what is so bad about them. First, they are challenging to set up. They require instantiating a real object, then altering or wrapping it, then providing it. Second, they decrease the comprehensibility of the test. Their use often raises questions like, what's the value of this test? What's real? What's fake? And can I trust that a passing test means it's working under real conditions? None of these comments from a teammate would make me feel like the tests I wrote were very effective. Whenever this happens, I rethink my tests and create new ones that are effective. We're going to get into some nitty-gritty details about how to create these test doubles. I use the term mocking to describe any sort of test double, not just mocks. A best practice emerges. Mocking in Swift via protocols. Not everyone considers this mocking. Dave Abrahams, in his WWDC 2015 session, Protocol-Oriented Programming in Swift, said, "This kind of testing is really similar to what you get with mocks, but it's so much better." He went on, "Mocks are inherently fragile. You have to couple your testing code to the implementation details of the code under test. From that session, we saw that protocols have many advantages over subclassing. these advantages will carry over into the mocks we write. But until a better name appears, I'll still use mock and stub to describe these test doubles, and almost all resources you read on the topic will follow this approach as well. Here are some more advantages of mocking with protocols instead of subclassing. First, it plays well with structs and classes. Now you can have one consistent approach to creating mocks throughout your code base. Protocols help when there's internal dependencies. An NSURL session could interact with a bunch of classes, most likely private ones. Maybe to ensure our tests work the way we want, we have to stub one or two dependencies. Now, since these are internal to the class, what happens when iOS 9 is released and these two classes are renamed, or two new dependencies are needed to be stubbed? When a superclass has stored properties, you must accept them. But this is not the case when your type conforms to a protocol. More best practices can be found, often coming from Java. We'll see how they work in iOS with Swift. They said, don't mock types you don't own. This includes the people working at ThoughtWorks in London who developed mock objects in 1999. They say so in their 2004 paper, Mock Roles, Not Objects. And this is the prevailing belief among developers who use mocks. It's bad to mock types you don't own for two main reasons. First, you have to be sure that the behavior you implement in a mock matches the external library. A lot of this depends on how well you know the external library and whether it's open or closed source. Second, the external library could change, breaking your mock. Based on past experience, you could guess how stable or volatile a library is, but that guess would be less accurate than one you could make about your own code. But we're iOS developers, and we work with a lot of Apple framework classes. Sometimes we should mock them. We should generally do this when setup is difficult, or if not, mocking might interfere with other tests. The two main classes often given as examples are NSUserDefaults and NSNotificationCenter. This is a user defaults mock. We'll see later that in practice, mocking NSNotificationCenter did not turn out to be as useful. I've heard the advice that when you replace Apple's classes with mocks, it's very important to only test the interaction with that class, not the behavior, as implementation details could change at any point. But NSUserDefaults hasn't changed in 15 years, and it's safe to say it won't change much in the future. This is a risk I'm willing to take in order to not accidentally mess up the real data in someone's NSUserDefaults. Say you want an app for people who want to keep up with the latest developments in time machines. We'll call it the Time Traveler Times. Here, we are testing that if the user defaults show that the user wants to receive breaking news or daily digest push notifications, the data provider's notification settings will reflect that. For my project, mocking NSNotificationCenter was not worth it. First, the mock was very complex. It took several days for me to write. And since it was used so widely throughout the code base, injecting it took a lot of work. It was also difficult to make the mock accurately reflect the real object. I resorted to ugly hacks that made the compiler happy, but limited the utility of the mock. Finally, In a notification center, mocking it avoids an issue, sending real notifications during tests, that I haven't found a compelling reason to be concerned about. If it ends up messing with our tests, I'll look into it. But a mock in a notification center is not how I would solve that problem. They said don't mock value types. This idea has already been embraced by the Swift community. You see a lot of people expressing the sentiment that Andy has in his controlling complexity in Swift talk. When you're doing simple data in and data out, you don't need mocking or stubbing. You can pass a value into a function, then look at the resulting value. One way to write less mocks is to use more value types. That removes the work and future maintenance costs of creating a mock. If you have a lot of classes lying around your code base, it can be hard to decide where to start. I was worried at first I would have to make huge changes to our code base in order to add more value types. Fortunately, you don't have to rewrite your entire code base. You also don't need to be an expert on value versus reference semantics. Joe works on the Swift programming language, and he gave me some great advice for how to approach incrementally refactoring your reference types to be value types. He said, try making your reference types immutable. An immutable class and a struct behave almost the same, so that gives you a common transition point. If you can successfully make the class immutable, then turning it into a struct afterward should be easy. I started looking at all the classes in our code base and asking, why is this a class? Sometimes it'll be because we needed the reference semantics. Other times our class inherited from NSObject to follow an implementation we saw elsewhere, but it didn't really need to. You will learn more about the decisions that went into the code your teammates wrote and hopefully find small ways to improve your code base. Through writing several mocks for our code base, I noticed some common characteristics of what makes a good mock. First, it's quick and easy to write. Yes, it takes time to decide which types to mock and what your approach should be. But if you're spending 3 straight days just creating a mock, you should think about whether it's a worthwhile investment of your time. Second, mock should be relatively short and not contain tons of information you don't need. If you're mocking a type you don't own, it shouldn't include any methods in the original type that you aren't using in your code base. Also, if you're setting the properties of a mock to useful default values, just set the required ones, not the optional ones. You also need a legitimate reason to not use the real object. Weigh the costs of writing and maintaining this mock versus the benefits of the fast, thorough, and reliable tests it should enable. I am thoughtful about what gets mocked and why. Fellow time travelers, let's look towards the future. What is the future of mocking frameworks in Swift? 3 main frameworks have emerged that take a similar approach. They are Dobby, Mock 5, and SwiftMock. They take the approach that you will still need to write your own mocks, but they provide helpers for setting expectations and stubbing out return values. Cuckoo is different from the others, since it uses a compile time generator to actually generate supporting structs and classes for you. It gets us closer to what we had in OCMock. It will create a mock for you from a protocol or a class, but not a struct. You can then stub out its methods, make calls, and verify behavior. You might be thinking, aren't we just going towards this new world described by Gary Bernhardt's boundaries talk and Annie Matuszak's controlling complexity and Swift talk? The idea that your code base will be made up of this functional core and imperative shell. You won't need mocks for the functional core because we're just working with value types. And the imperative shell is so thin, you can just use integration tests for it. From what I have explored in Swift, this type of architecture is mostly in toy apps and in its early stages. This is why I was so excited by Ayaka's talk yesterday. This is the first time I have heard about this architecture being used in production iOS apps. But for almost all of us, we're not there yet. Unless you want to do a rewrite of your app's architecture, you will need mocks to write good tests. So, my wrap-up. If you want to improve your code base, write tests. Mocks allow you to write great tests. Finally, I want you to create simple mocks that will last. So write mocks and use them for great good. Thank you.